J. Ward Moody, and it's my privilege to introduce our speaker tonight. First, just a little bit about the Summerhays Lecture series. This series is made possible by a generous gift from Hiram Summerhays' son, Bryant, who I believe is with us here tonight. I didn't see him come in, but I'm sure he is. Summerhays' family has a history of supporting astronomy at BYU, having given money to purchase the star projector for the original planetarium over 50 years ago. In this series, we have the privilege of honoring Hiram Summerhays and his lifelong love of astronomy, science, and the gospel. These lectures take place every year at or near the time of the autumnal equinox. The significance of this time to astronomy is apparent. It's when the days and nights are each 12 hours long and signals the beginning of fall. The autumnal equinox is also the time when Joseph Smith first saw the golden plates, was 4 times instructed by the angel Moroni, and received the place to translate. The dual meaning of this date makes it a natural choice for these lectures. I always thought it was a nice touch. Truth is not in conflict with itself. Truth established through revelation is sure and certain. Scientific inquiry has established ideas that have thus far withstood the test of time and surely must have truth within them. It is incumbent upon those who seek insights into truth to mesh where possible her parts at their proper interface. We establish bridges between our scientific and religious knowledge best if we pursue their discovery through study, faith, and dialogue. The charter of this series is to explore the bridge work connecting the truths that are revealed and the truths that, to paraphrase James E. Talmage, are written in the world around us. We at BYU are admonished to teach not even the mathematical tables without the Spirit of the Holy Ghost, a charge that is taken seriously. But we are also taught by the Savior in Doctrine and Covenants chapter 9 that we must first study things out in our minds before their accuracy and truth will be affirmed or denied to us. In this lecture series, we encourage searching things out in our minds while remaining in tune with promptings from on high. We have as our speaker here tonight Dr. Daniel Peterson, a professor of Islamic Studies and Arabic here at BYU. Dr. Peterson received a bachelor's degree in Greek and philosophy from BYU and, after several years of studying in Jerusalem and Cairo, returned to his native Southern California to earn a PhD in Near Eastern languages and cultures from UCLA. Dr. Peterson is the author of several books and numerous articles on Islamic and Latter-day Saint topics, and has lectured across the United States, Europe, Australia, New Zealand, and at various Islamic universities in the Near East and Asia. He writes a weekly column in the Deseret News entitled Defending the Faith, and with William Hamblin of the Department of History, contributes to a semi-weekly column on world religions. Dr. Peterson has served in many capacities, including chairman of the board for the organization originally known as FARMS, the Foundation for Ancient Research and Mormon Studies, which is currently named the Neil A. Maxwell Institute for Religious Scholarship. During his recently ended quarter century of involvement, holy cow, Dan. FARMS published 3 regular journals, scores of books, sponsored numerous symposia on topics related to the LDS faith and others, produced a computer-digitized version of the Dead Sea Scrolls, electronically recovered damaged documents from the ruins of Herculaneum in Italy, Petra in Jordan, Bonampak in Mexico, and with the Vatican Apostolic Library in Rome, electronically published editions of ancient Syriac Christian manuscripts. Dr. Peterson is the founder and former editor-in-chief of BYU's 4-part Middle Eastern Text Initiative, which publishes through the prestigious University of Chicago Press dual-language editions of classical works of medieval Arabic and Persian philosophy, Arabic medicine and science, and early Syriac and Christian Arabic literature. For this work in 2007, Dr. Peterson was named a Utah Academy Fellow and declared a lifetime member of the Utah Academy of Sciences, Arts, and Letters. Dr. Peterson is a former missionary, bishop, and 8-year member of the church's Gospel Doctrine Writing Committee. He is married to the former Deborah Stevens of Lakewood, Colorado, and they are the parents of 3 sons. Dr. Peterson.
Thank you. It's an honor to have been invited to do this lecture, and it's given me a chance to put down on paper, into the computer, some thoughts that I've been mulling over but never had written down until now. And this is a good trial run, and if things are thrown at me and catcalls start coming from the audience, I'll have learned something very valuable. I've done something that I don't typically do, which is that I've written the talk out. I knew that it was eventually supposed to be published and thought I might as well get a leg up on it. There's a lot of stuff that I wanted to cram into it, and I kept cramming and cramming and cramming, so I apologize if it goes long. I'll try to be quick and efficient up here, and I have to see if this works. So far, no. Okay. I'll start. The heavens declare the glory of God, wrote the ancient psalmist, and the firmament showeth his handiwork. To pre-modern thinkers, the order of the visible universe, the fact that it is, in Greek terms, a cosmos rather than a chaos, was clear evidence, almost self-evident proof, of divine design and providence. Here's a modern, perhaps clearer translation of Psalm 19, 1-4. The heavens declare the glory of God. The sky displays his handiwork. Day after day it speaks out, night after night it reveals his greatness. There is no actual speech or word, nor is its voice literally heard, yet its voice echoes throughout the earth, its words carry to the distant horizon. Now there may have been no actual speech or word, but many pre-modern thinkers believed that there was a genuine sound, the so-called music of the spheres. This music was created, they believed, as the enormously vast spheres of the various planets, the sun, the moon, and the stars turned upon their axes. It was an expression, in principle an audible one, of the intelligibility, the harmonious order, the literal rationality of the universe. Well, point it up here? That's where, okay, good to know. Because if we keep doing this, this is going to go several hours. All right. I think I'm already behind. There he is. Accepting the model apparently devised by Eudoxus of Cnidus, Aristotle explained the movement of heavenly objects across the sky as the result of uniform circular motions of celestial spheres. Each sphere had its own mover. These movers would eventually appear in the planetary rulers or oyarses of C.S. Lewis's Paralandra science fiction trilogy. But at the summit of the universe was the unmoved mover, the ou kinoumenon kine, also known as the prime mover. As implied by the name, the unmoved mover moves other things, but is not itself moved by anything else. In the 12th book of his Metaphysics, also known as Book Lambda, Aristotle describes the unmoved mover as perfectly beautiful and explains that its entire activity consists in the contemplation of the only thing in the universe worthy of its attention, itself. Aristotle famously taught that there were four kinds of causes: material, formal, efficient, and final. The existence of a statue, for example, would be impossible without the marble of which it is made, its material cause. But the marble is insufficient by itself to make a statue. Without having been formed, this is its formal cause, it would be just a block of stone. So a sculptor is required, an efficient cause, to transform that piece of rock into a statue. No sculptor, no sculpture. But why would the sculptor do it? She needs a motive, and that is the final cause. It's the reason why. Parenthetically, I note that modern science begins, according to many modern philosophers and historians of the subject, when it jettisons fruitless concern with Aristotle's question of final causation, or teleology, and brackets the issue of conscious purpose in nature and natural processes. Aristotle's unmoved mover is a final cause, not an efficient cause, of the motion of the spheres. That is to say that the unmoved mover doesn't push them, rather it inspires them. Never-ending circular motion being the most perfect kind of movement available to material objects, their closest approximation to the timeless eternity of the self-contemplating unmoved mover, the spheres turn forever on their axes, and in doing so produce a marvelous, perpetual, though humanly unheard chord. This notion results, among other things, in a scene, an amusing one to me, in the delightful philosophical novel Hayy ibn Yaqzan by the 12th century Andalusian Arab thinker Ibn Tufayl. Marooned on a desert island, the protagonist, for a time, spends several hours daily spinning in a circle in order to imitate the celestial spheres. A similar idea also seems to be behind the practice of the famous whirling dervishes of the Mevleviya Sufi mystical order in Anatolia and elsewhere in the Middle East. More to the point, the concept of the unmoved mover was highly influential in medieval philosophy and theology, both East and West. It's fundamental, for example, in Islamic theology to certain forms of what has been called the Kalam cosmological argument for the existence of God, and it was used by such important Muslim thinkers as Avicenna, Averroes, and others. The illustrious 13th century philosopher and theologian St. Thomas Aquinas, too, used the idea as the basis for an argument for the existence of God in his famous 5 Ways, or Quinque Viae. I'd like to return, though, to the music of the spheres. In the 6th book of his De Republica, the 1st century BC Roman statesman, philosopher, and lawyer Marcus Tullius Cicero includes a fictional dream vision of the Roman general Scipio Aemilianus, which he sets a couple of years before the destruction of Carthage in North Africa in 146 BC. Scipio Aemilianus would be the Roman commander during that siege. Upon his arrival in Africa, Scipio is visited by his dead adoptive grandfather, Scipio Africanus, the illustrious hero of the Second Punic War. He finds himself looking down upon the doomed city of Carthage from a high place which was clear and shining in the radiance of starlight. He has, in fact, ascended high into the heavens. Here, the younger Scipio poses a question to his deceased ancestor. I gazed at all these things in amazement. Then, pulling myself together, I said, "What is this sound so loud and yet so sweet that fills my ears?" That, he said, his grandfather, is the sound produced by the impetus and momentum of the spheres themselves. It is made up of intervals, which, though unequal, are determined systematically by fixed proportions. The blend of high and low notes produces an even flow of various harmonies. Such vast motions cannot sweep on in silence, and nature ordains that low notes should be emitted by one of the boundaries, and high notes by the other. From the uppermost of the heavenly orbits, that which carries the stars, comes a high note, with frequent vibrations, in that its cycle is more rapid. The deepest note emanates from the lowest orbit, that of the moon. The Earth, which is the 9th sphere, remains fixed and immobile in one place, filling the central position of the universe. Those 8 rotating spheres, of which 2, being an octave apart, produce the same effect, give out 7 distinctive sounds according to their intervals. That number is more or less the linchpin of everything. Filled with this sound, people's ears have become deaf to it. The noise of the whole universe, revolving as it does at an enormous speed, is so loud that human ears cannot take it in, just as you cannot look straight at the sun, because your sight and vision become overwhelmed by its rays. Now, clearly, the noise of the spheres isn't merely noise. It's harmonious, it's fine-tuned, it's music. And this concept survived for a very long time across languages and cultures. Listen as Lorenzo explains the idea to Jessica in William Shakespeare's The Merchant of Venice, written probably between 1596 and 1598. How sweet the moonlight sleeps upon this bank. Here will we sit and let the sounds of music creep in our ears, soft stillness, and the night become the touches of sweet harmony. Look how the floor of heaven is thick inlaid with patterns of bright gold. There's not the smallest orb that thou beholdst, but in his motion like an angel sings, still choiring to the young-eyed cherubims. Such harmony is in immortal souls, but whilst this muddy vesture of decay doth grossly close it in, we cannot hear it. This, in general, is the world in which our pre-modern ancestors lived. So obvious to the Apostle Paul was the evidence for a divine lawgiver given by the physical universe, that in his view it left humanity with no plausible way of claiming ignorance as a defense for our violations of God's moral commands. For the invisible things of him from the creation of the world are clearly seen, Paul explained to the Romans, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse. All things, Alma the Younger explains to the Antichrist Korihor, denote there is a God, yea, even the earth and all things that are upon the face of it, yea, and its motion, yea, and also all the planets which move in their regular form, do witness that there is a supreme creator. Now, the classic philosophical statements of this argument come from St. Thomas Aquinas. It's the last of his famous 5 Ways. The 5th way is taken, he says, from the governance of the world. We see that things which lack knowledge, such as natural bodies, act for an end. And this is evident from their acting always, or nearly always, in the same way, so as to obtain the best result. Hence it is plain that they achieve their end not fortuitously, but designedly. Now, whatever lacks knowledge cannot move towards an end, unless it be directed by some being endowed with knowledge and intelligence, as the arrow is directed by the archer. Therefore, some intelligent being exists by whom all natural things are directed to their end, and this being we call God. Now, that is not God, that is William Paley. Another very famous non-scriptural statement of this view is that of the English theologian William Paley in his 1802 book, Natural Theology. In Crossing a Heath, he wrote, "Suppose I pitched my foot against a stone and were asked how the stone came to be there. I might possibly answer that for anything I knew to the contrary, it had lain there forever, nor would it be very easy to show the absurdity of this answer. But suppose I had found a watch upon the ground, and it should be inquired how the watch happened to be in that place. I should hardly think of the answer which I had given before, that for anything I knew the watch might have always been there. Yet why should not this answer serve for the watch as well as for the stone? Why is it not as admissible? When we come to inspect the watch, we perceive what we could not discover in the stone, that its parts are framed and have been put together." Okay, we notice more. We find a series of wheels, the teeth of which catch in and apply to each other, conducting the motion to the balance and from the balance to the pointer. Further, we notice that the wheels are made of brass to prevent rust, the springs of steel, no other metal being so elastic, that over the face of the watch there is placed a glass, a material employed in no other part of the work, and without which the hour could not have been seen without opening the case. This mechanism being observed, the inference we think is inevitable. The watch must have had a maker and been designed for a purpose. Every observation which was made concerning the watch may be repeated with strict propriety concerning the eye, animals, plants, indeed all the organized parts of the works of nature. The eye would be alone sufficient to support the conclusion which we draw from it as to the necessity of an intelligent creator. Curiously, Cicero, too, had offered an argument from design that used a device for the telling of time. "When you see a sundial or a water clock," he wrote in De Natura Deorum, on the nature of the gods, "you see that it tells the time by design and not by chance. How, then, can you imagine that the universe as a whole is devoid of purpose and intelligence when it embraces everything, including these artifacts themselves and their artificers?" But although the 19th century Jesuit priest and poet Gerard Manley Hopkins could still exclaim that the world is charged with the grandeur of God, scientific discoveries had seriously undermined that view, or at least were being claimed to have done so, by the time of his too young death in 1889. The serious subversion had begun, or so the story is often told, with the Copernican revolution's dethronement of Earth and humans from their privileged place at the center of the universe. I'll return to this so-called Copernican principle, or to this principle of mediocrity, as it's also sometimes labeled, in a moment. It continued, rather ironically, given his devout personal religiosity, with Sir Isaac Newton's portrayal of that universe as governed by a remorseless chain of cause and effect, operating under mathematically rigorous physical laws. And it seemed to have been proven by Darwin's apparent demonstration that life in all its varieties had emerged as a result merely of purposeless chance. Biology, says the evolutionary biologist and ardently vocal atheist Richard Dawkins, is the study of complicated things that give the appearance of having been designed for a purpose. Although atheism might have been logically tenable before Darwin, Darwin made it possible, Dawkins says, to be an intellectually fulfilled atheist. And the title of one of his books, The Blind Watchmaker, is an obvious reference to William Paley and to the apparent overthrow of Paley's argument from design to the existence of God. The famous Victorian art historian and critic John Ruskin complained at the damage that new fossil discoveries and Darwin's explanations of them were doing to the comforting Christian beliefs of his childhood. "If only the geologists would let me alone," he wrote, "I could do very well, but those dreadful hammers, I hear the clink of them at the end of every cadence of the Bible verses." The dark religious doubt that settled upon many thinkers in Victorian England is eloquently expressed in Matthew Arnold's famous poem, Dover Beach. "The sea is calm tonight, the tide is full, the moon lies fair upon the straits. On the French coast the light gleams and is gone. The cliffs of England stand glimmering and vast out in the tranquil bay. Come to the window, sweet is the night air. Only from the long line of spray where the sea meets the moon-blanched land, listen, you hear the grating roar of pebbles, which the waves draw back and fling at their return up the high strand, begin and cease and then again begin, with tremulous cadence slow, and bring the eternal note of sadness in. Sophocles long ago heard it on the Aegean, and it brought into his mind the turbid ebb and flow of human misery. We find also in the sound a thought, hearing it by this distant northern sea. The sea of faith was once too at the full, and round earth's shore lay like the folds of a bright girdle furled. But now I only hear its melancholy, long withdrawing roar, retreating to the breath of the night wind, down the vast edges, drear and naked shingles of the world. Ah, love, let us be true to one another, for the world which seems to lie before us like a land of dreams so various, so beautiful, so new, hath really neither joy, nor love, nor light, nor certitude, nor peace, nor help for pain. And we are here as on a darkling plain, swept with confused alarms of struggle and flight, where ignorant armies clash by night. The more the universe seems comprehensible, says the Nobel laureate physicist Steven Weinberg of Princeton, rather in the spirit of Matthew Arnold's poem, the more it seems pointless. But does it really? We'll try this again. I said that I wanted to come back to Copernicus, but first we need to lay out some basic ancient physics. In classical Greek thought, and derivatively among the Romans, and in the Latin Middle Ages and the Renaissance, as well as in the Arabic and Islamic tradition, the four fundamental constituent elements of the world in which we live were earth, water, air, and fire. Quite often added to these was a fifth element, or as it came to be called, a quintessence, with quint coming from the same Latin root, quintus, or fifth, that gives us the word quintuplets. In Greek, the quintessence was known as ether. According to Plato, these four elements were recognized by the pre-Socratic philosophers, and specifically by the 5th century BC Sicilian philosopher Empedocles, who called them the four roots, or rhizomata. Plato himself appears to be the first to call them elements, stoicheia, and to refer to them that way. In his treatise on generation and corruption, Aristotle explains that air is primarily wet and secondarily hot, while fire is primarily hot and secondarily dry. By contrast, earth is primarily dry and secondarily cold, while water is primarily cold and secondarily wet. According to the 3rd century AD Roman physician and philosopher Galen, he could be considered 2nd century, these four elements were used by Hippocrates when he described the human body in terms of the so-called four humors, which it was essential to keep uncorrupted and in harmonious balance. These were yellow bile, cholé, which he associated with fire, black bile, melancholé, which he associated with earth, blood, air, and phlegm, water. When a patient suffered from an imbalance, a surplus or corruption of one of the fluids, his personality and physical health could be affected. We no longer accept the four humors, of course, but we still use language derived from the theory, including the word bilious, the notion that an impudent individual has a lot of gall. Thus, a person who is hopeful or optimistic is sanguine, from a word for blood. Someone who's easily angered or bad-tempered is choleric. Someone who's who's despondent or sleepless suffers from melancholy, black bile, while a calm and unemotional person is phlegmatic. Aristotle felt obliged to add ether as the quintessence because, while the world in which we live, and in which fire, earth, air, and water are regularly experienced realities, is plainly subject to coming to be and ceasing to be, to change and decay, the region beyond the moon didn't seem to him subject to generation and corruption. Heavenly bodies seemed to move regularly, unchangingly, almost in a sense timelessly. The sublunary sphere, as it was called, was fundamentally distinct from the superlunary sphere. Thus, the heavens must not be composed of the familiar four elements, but of something very different and unchangeable. This is why Galileo's discovery of sunspots was so controversial and so unwelcome, not because it conflicted with church dogma. The simplistic portrayal of Galileo's trial as a fight between science and Christian doctrine, which is how it was taught to me, is at the best a gross distortion, but because it contradicted the authority of Aristotle. This concept of the five classical elements may derive ultimately from Babylonian mythology, since the Enuma Elish, a text probably composed between the 18th and 16th centuries before Christ, describes five strikingly parallel personified cosmic elements: sea, earth, sky, fire, and wind. On the other hand, there's also mention in ancient Hinduism of four states of matter, to which a fifth element is added that pertains to things that transcend our physical world. The Pancha Mahabhuta, or five great elements of Hindu tradition, as they're called, are earth, water, fire, air, or wind, and then ether or void. According to one of the principal texts of Hindu philosophy, the 19th century AD Tattva Kaumudi of Vakaspati, the five elements are associated with the five senses and act as the gross medium for the experience of sensations. The basest element is earth, which can be perceived by all five senses: hearing, touch, sight, taste, and smell. The next higher element, water, has no odor, but can be heard, felt, seen, and tasted. Next comes fire, which can be heard, felt, and seen. Air can be heard and felt. And finally, akasha, or ether, is the medium of sound, but is inaccessible to the other senses. Note, please, the hierarchical aspect of the Hindu conception. The basest element in the scheme is earth. In ascending order thereafter come water, then fire, then air, and finally the ether. Compared to the Western system, which is very nearly, though not quite, the same, According to Aristotle, the four elements ascend or descend toward their natural place. Earth, in particular, sinks to the bottom. Thus, the idea that the planet Earth held a privileged place in the Ptolemaic cosmos is fundamentally mistaken. The Earth wasn't so much at the center of the universe as it was at the universe's lowest point, the furthest place away from the divine. That helps to explain why Scipio Aemilianus, in Cicero's recounting of his dream, is so unimpressed with our planet when he sees it from the heavens. When I beheld the whole universe from that point, everything seemed glorious and wonderful. There were stars which we've never seen from this earth of ours, each of a size which we have never imagined to exist. The smallest star, by which he means the moon, which was furthest from heaven and nearest to earth, was shining with a light not its own. The spheres of the stars easily exceeded the earth in size. Now the earth itself seemed so small to me that I felt ashamed of our empire, whose extent was no more than a dot on its surface. Ancient and medieval ascension stories from around the world are agreed that one needs to climb a mountain or to climb through the heavens in order to reach God, and that the world, our planet, must be left far below. An exceptionally clear illustration of this can be found in the story of the Prophet Muhammad's ascent through the seven spheres to the presence of God, but such accounts are common to many religions and cultures. Later, an essentially Ptolemaic cosmos figures in Islamic philosophers such as Avicenna, Averroes, and the early 11th century Al-Kirmani as not merely an account of the physical universe, but a path to salvation. God, although non-physical in these systems, remains at the top, as it were, associated with the empyrean, beyond the fixed stars, while the moon marks the boundary between the celestial world above and the transient, changeable world in which we live. It's equated with Aristotle's active intellect, and it represents the gateway through which our contemplation can soar up to God. In the Sufi mystical tradition of Islam, analogously, mystics hope to rise symbolically or metaphorically through the spheres in order to achieve union with the One. And both the philosophical and mystical traditions draw upon the thought of Plotinus, the 3rd century founder of Neoplatonism, who so disdained the earth and his own mortal life upon it that Porphyry, his disciple and biographer, said of him that he felt ashamed to have a birthday. Perhaps the clearest illustration of the less than honorable place that the center of the geocentric cosmos held in pre-modern times can be found in the Divina Commedia of the great early 14th century Italian poet Dante Alighieri. It's good to have associate deans working for you. Okay. In his Inferno, the intensity of the punishments of hell increases in tandem with the gravity of the sins to which they're attached, as the poet and his guide Virgil go deeper and deeper toward the center of the earth. And at the very center, which some mistaken views might suggest ought to be the most privileged place in the cosmos, they find Lucifer, half immobilized for eternity, in ice. The center of the pre-modern universe isn't especially blessed, it's hell. And thereafter, in the Purgatorio, when the poet is making his way up Mount Purgatorio, accompanied first by Virgil and then by Beatrice, he is moving away from the center of the earth and the universe, commencing an ascent into the heavens that will continue in the 3rd volume of his trilogy, the Paradiso. In any case, it's important to recall that the Bible itself never ascribes any doctrinal, moral, or spiritual significance to the physical location of the earth within the universe. The Ptolemaic system arose quite independently of the Bible. The 2nd century astronomer and mathematician Claudius Ptolemaeus was an Alexandrian pagan. Copernicus, by contrast, was a canon of the Roman Catholic Church. Moreover, such books as The Privileged Planet by the astronomer Guillermo Gonzalez and Rare Earth by geologist Peter Ward and astronomer Donald Brownlee have demonstrated in detail that our planet is anything but the common, unremarkable place that the Copernican principle supposedly makes it. My major point here is that the dogma that the Copernican revolution involved displacing the Earth from a privileged central biblical location in the universe is without historical basis, and that Copernicus himself certainly didn't regard his work as a contribution to a more secular view of the cosmos. The Bible does, however, suggest that the universe as we know it was deliberately made by God. He hath made the earth by his power, sings the psalmist. He hath established the world by his wisdom, and hath stretched out the heavens by his discretion. But are there any actual signs of that? Writing in 1930, the English mathematician, physicist, and astronomer Sir James Jeans contended that the stream of human knowledge is heading towards a non-mechanical reality. The universe begins to look more like a great thought than a great machine. Mind no longer appears to be an accidental intruder into the realm of matter. We're beginning to suspect that we ought rather to hail it as the creator and governor of this realm. But this points to something that is simultaneously entirely obvious and yet potentially very puzzling. The eternal mystery of the world, remarked Albert Einstein, is its comprehensibility. In his autobiography, Darwin mentioned one source of conviction, as he put it, of the existence of God, connected with the reason and not with the feelings that had impressed him. This follows, he said, from the extreme difficulty, or rather impossibility, of conceiving this immense and wonderful universe, including man with his capacity of looking far backwards and far into futurity, as the result of blind chance or necessity. When thus reflecting, I feel compelled to look to a first cause, having an intelligent mind in some degree analogous to that of man, and I deserve to be called a theist. Immediately, though, he expresses doubt. This conclusion was strong in my mind about the time, as far as I can remember, when I wrote The Origin of Species, and it is since that time that it has very gradually, with many fluctuations, become weaker. But then arises the doubt, can the mind of man, which has, as I fully believe, been developed from a mind as low as that possessed by the lowest animals, be trusted when it draws such grand conclusions? With me, the horrid doubt always arises whether the convictions of man's mind, which has been developed from the mind of the lower animals, are of any value or at all trustworthy. Would anyone trust in the convictions of a monkey's mind, if there are any convictions in such a mind? The fact remains, though, that humankind has produced both Newton and Einstein, and for that matter Darwin. It has been able to send men to the moon and spacecraft to Mars, to decipher the structure of DNA and of the atom, and that is, I believe, a significant fact. Permit me to introduce briefly the English theoretical physicist Sir John Polkinghorne. From 1958 to 1979, he taught mathematical physics at the University of Cambridge, and in 1974, he was elected a Fellow of the Royal Society. He resigned his professorship, however, in order to study for the priesthood. He has since been ordained an Anglican priest, served as president of Queen's College, Cambridge from 1988 to 1996, and written more than 24 books on the relationship between science and religion. We are so familiar, he has written, with the fact that we can understand the world that most of the time we take it for granted. It's what makes science possible. Yet it could have been otherwise. The universe might have been a disorderly chaos rather than an orderly cosmos, or it might have had a rationality which was inaccessible to us. There is a congruence between our minds and the universe, between the rationality experienced within and the rationality observed without. In the beginning was the Word, begins the Gospel of John, and the Word was with God. And the Word was God. The same was in the beginning with God. All things were made by him, and without him was not anything made that was made. In him was life, and the life was the light of men. And the light shineth in darkness, and the darkness comprehended it not. He was in the world, and the world was made by him, and the world knew him not. And the Word was made flesh, and dwelt among us. And we beheld his glory, the glory as of the only begotten of the Father, full of grace and truth. In the original Greek of John 1:1, the word translated as word is logos, which is the source of our terms logic, biology, dialogue, geology, meteorology, and so forth. It bears closer examination. In the late 6th and early 5th centuries before Christ, Heraclitus used the term logos to denote a cosmic principle of order and knowledge. In the philosophy of the Stoics, it was the divine principle that pervades the entire universe. Philo of Alexandria, a very near contemporary of the Gospel of John, introduced it into Jewish philosophical theology as an intermediary between the world and his distant, utterly transcendent middle Platonic God. It's fascinating in that light to see John use that very term for God and Christ. It's also fascinating to read this passage from Sir Arthur Eddington, a British astrophysicist who died in 1944. The idea of a universal mind or logos would be, I think, a fairly plausible inference from the present state of scientific theory. Goethe's Faust famously struggles with the translation of logos, and for very good reason. The word is semantically packed. One of the possibilities that he entertains is im Anfang war der Sinn. In the beginning there was mind. From the intrinsic evidence of his creation, wrote Sir James Jeans, the great architect of the universe now begins to appear as a pure mathematician. The great Galileo had already noticed this. Philosophy, he said, is written in this grand book, I mean the universe, which stands continually open to our gaze, but it cannot be understood unless one first learns to comprehend the language in which it is written. It is written in the language of mathematics. And yet, despite Darwin's misgivings, we can plainly learn to read that language. But this is surprising, as the Hungarian-American theoretical physicist and Nobel laureate Eugene Wigner noticed in a famous paper entitled The Unreasonable Effectiveness of Mathematics. How is it, he wondered, that mathematicians consider their studies creating mathematics, and that we then subsequently find that their mathematical work actually applies to the real outside world? Our minds seem in some real way to be fitted to the universe in which we live, and far beyond what mere Darwinian survival would require. The universe, it seems, is rational, and our minds are demonstrably congruent with its rationality. This is striking. Now this, you may be surprised, is an actual photograph of the Big Bang. Most of you didn't know that color photography existed at that early date. At the opening of the 20th century, the reigning presumption was that the universe was static. In what he later lamented as one of the greatest mistakes of his life, Einstein's 1915 theory of general relativity even introduced an artificial term now known as the cosmological constant in order to maintain that static character and to hold gravity at bay, which would otherwise have had the universe collapsing back upon itself. During the 1920s, though, evidence was found to suggest that, in fact, the universe was expanding. Crucially, Edwin Hubble, using the newly constructed 100-inch telescope on Mount Wilson in Southern California, the mountain that I saw virtually every day for nearly the first 2 decades of my life, the telescope that I regularly visited on school field trips. Though being young and stupid, I didn't realize its historic significance until years later. Hubble discovered the red shift of the light from distant galaxies. This phenomenon, analogous to the Doppler effect that we commonly experience with rapidly approaching and then receding sirens and motorcycles, indicated that these galaxies were flying away from us at incredible speeds. The obvious implication of this was that at some point in the very distant past, the universe had been very tightly, inconceivably tightly, packed together. In 1948, Sir Fred Hoyle and others argued that while the universe was expanding, it had never had a beginning. Instead, matter was continuously being created in order to fill the void that would otherwise be left by expansion. The late Christopher Hitchens claimed that Hoyle's motive for proposing this theory was somehow to preserve his religious beliefs. But the truth, as with so many other claims asserted by Mr. Hitchens, was precisely the opposite. Fred Hoyle was an atheist, and he didn't like a scientific concept that looked suspiciously to him like divine creation. Amusingly, during a December 1948 meeting in Leningrad, in the days of Comrade Stalin, of blessed memory, Soviet astronomers insisted on the need to combat the reactionary idealistic theory that the universe had an origin. If accepted, such a notion would, they claimed, support the cause of clericalism, that is, of religion. And they surely took no comfort in the fact that one of the chief theoreticians of what Hoyle had derisively labeled the Big Bang was a Belgian physicist and priest named Georges Lemaitre. And there's another one of him. Hoyle's steady-state theory was still a very live option when I was in school, even though in 1965, Arno Penzias and Robert Wilson at Bell Labs in New Jersey had detected the faint but persistent echo of the primordial Big Bang. At first, they thought it was simply pigeons roosting on their antenna, but it won them the Nobel Prize. Today, therefore, it's virtually universally accepted that the visible universe originated in a massive explosion of both time and space, roughly 14 billion years ago. Since then, it has continued to expand and to cool. I need to say something quickly and parenthetically here about scientific notation. I realize that scientific notation is absolutely basic. For many at a lecture sponsored by, of all things, BYU's College of Physical and Mathematical Sciences. However, since this is a cross-disciplinary lecture series and lecture, and since there are probably some here whose math, like mine, is a bit rusty, I think I'll make a quick explanation. When you see the number 10 to the second power, that is equivalent to 10 times 10, or in other words, to the number 100. An easy way to understand it is that it's 1 followed by 2 zeros. Accordingly, 10 to the third power is 10 times 10 times 10, or 1,000, or to put it another way, it's 1 followed by 3 zeros. Scientists are accustomed to use such notation because they're often dealing with inconceivably large numbers, or inconceivably small ones, which would be cumbersome, or even, as we shall soon see, utterly impossible to write out fully in conventional notation. The number of atoms in the universe, for example, has been estimated to be somewhere between 10 to the 78th and 10 to the 82nd power. It would take you a bit of time to write either of those numbers out, and even longer to count that many particles. Now we're ahead of ourselves. Oh well. But you might say, even 82 zeros isn't all that big a figure. How large a number can it possibly denote? The answer is related to what's sometimes called the miracle of compound interest, and it shows the sheer power of geometric or exponential growth. Professor Koalas and I go back a very, very, very long way, and I may soon start telling you stories about Professor Koalas. Yeah, you can tell some about me too. That's the trouble. So I probably won't. It's mutual assured destruction. The story is told. It first appears in Ferdowsi's great Persian epic poem, the Shahnameh, or Book of Kings, but it's also picked up by Arab historians such as al-Masaudi, of the Indian mathematician who supposedly invented the game of chess. When he presented the game to his royal patron, the king was so delighted with the new game that he offered its inventor anything he wanted as a reward. Modestly, the man replied that all he desired was some wheat, or in some versions, rice. How much? Oh, merely a single grain on the first square, 2 on the second, 4 on the third, and so on, doubling with each successive one of the 64 squares on the chessboard. The king, who was a bit naive, mathematically speaking, was delighted, or some accounts say offended, by the low price, and ordered his treasurer to count the grain out immediately. But there wasn't enough grain in the treasury to complete the task, because by the 64th square, the number of grains required to pay out the king's promised reward would be, well, I'm not going to attempt to read it to you. But what about negative numbers in scientific notation? Again, they're used when scientists are talking about extremely small quantities. When, for example, you see the number 1 times 10 to the minus second power, that's equivalent to 0.01. An easy way to understand that is that it's the number written in normal script, in this case 1, with the decimal point moved two places to the left. Thus 1 becomes 0.01. Accordingly, 7.8 times 10 to the minus third power is 0.0078. You won't remember all that, but back now to cosmology. Another one. In the first epoch of the universe's history, the Planck era, which lasted roughly 5 times 10 to the minus 44th seconds, that's a period represented by a decimal point followed by 43 zeros and then a 5, the temperature of the cosmos was 1.4 times 10 to the 32nd degrees Kelvin. String theory suggests, although it seems virtually impossible to prove, that there were at this time 10 or 11 dimensions, which basically coalesced into the 4 dimensions of space-time familiar to us now. The 4 fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, had not yet come into existence. But things were changing at an inconceivably rapid pace. The universe grew by a factor of 10 to the 35 within 10 to the minus 32 seconds. In other words, from being smaller than a subatomic particle, it swelled to about the size of a grapefruit. Variations began to appear. The universe became less homogeneous. Matter began to clump, forming the seeds of what would later be stars and galaxies. Hydrogen eventually appeared, and then to a lesser degree helium, and then following that, and to a much lesser degree, lithium, the 3 lightest elements. But the production of oxygen, magnesium, silicon, iron, and sulfur, the chemical elements that make up 96% of the mass of the Earth and are essential to life, was still in the future. They awaited the process of stellar nucleosynthesis. Incidentally, the age of 14 billion years for our universe was determined by a famous astronomer named Alan Sandage, who also discovered the first quasar. Dr. Sandage lived in San Gabriel, California, just a few blocks from my childhood home. Another fact that I learned to my shame only quite recently. Significantly for this lecture, he became a committed Christian in his last years, having been deeply impressed by the remarkable orderliness of nature. Astoundingly, when the universe came into being with the Big Bang, it was virtually instantaneously endowed with the potential for life, and even for complex and intelligent life. Scientific study of the universe in recent decades has revealed an intricate and finely tuned ensemble of factors that make our existence possible. The seminal text is probably Brandon Carter's 1974 paper, Large Number Coincidences, the Anthropic Principle in Cosmology. These factors, sometimes, as in the title of Brandon Carter's paper, question-beggingly called anthropic coincidences, are necessary conditions for life as we know it and as we can conceive it. For that reason, some have argued that the proper term ought to be biocentric rather than anthropic. That they exist is not in question. It's their significance that's debated. There are various lists of these, some fairly long. For the sake of brevity, though, I'll concentrate on just 6 of them, as they're listed in the appropriately titled book, Just 6 Numbers, written by Sir Martin Rees, Astronomer Royal of England, former Master of Trinity College, Cambridge, and past President of the Royal Society. 2 of them, he says, relate to the basic forces, 2 fix the size and overall texture of our universe, and determine whether it will continue forever, and 2 more fix the properties of space itself. The first one, the ratio of the electromagnetic force to the force of gravity, N. This can also be expressed as the electrical force between two protons divided by the gravitational force between them. N equals 1, I'm going to read it to you, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, I won't give you the decimal point 0, 0. If it were slightly smaller than the value that we actually see, says Professor Rees, quote, only a short-lived miniature universe could exist. No creatures could grow larger than insects, and there would be no time for biological evolution. Number 2, the strong nuclear force. The strong nuclear force accounts for the firmness with which atomic nuclei bind together. It determines how long stars live. It has a value of 0.007, and it controls the power from the sun and, more sensitively, how stars transmute hydrogen into all the atoms of the periodic table. Without the heavier elements, especially carbon, life as we know it would be impossible. But if the value of this constant were 0.006 or 0.008, neither they nor we would exist. Number 3, the amount of matter in the universe, symbolized by omega. The cosmic number omega is a measure of the total amount of material in the known universe, regardless of the form in which it occurs, whether in galaxies and diffuse gas or in so-called dark matter and dark energy. Omega answers the question of the relative importance of gravity and expansion energy in the universe after the Big Bang. If this ratio were too high relative to a particular critical value, explains Professor Rees, the universe would have collapsed long ago. Had it been too low, no galaxies or stars would have formed. The initial expansion speed seems to have been finely tuned. It's rather, he says, like sitting at the bottom of a well and throwing a stone up with such precision that its rise comes to a stop at precisely the top of the well. At 1 second after the Big Bang, he continues, omega cannot have differed from unity by more than 1 part in a million billion. That is, in 1 times 10 to the 20, or 1 in 10 to the 15th power, sorry. The 4th is cosmic repulsion, or lambda. In 1998, cosmologists recognized the importance of cosmic anti-gravity in controlling the expansion of the universe. In particular, they noticed that it becomes increasingly important as the expanding universe becomes more diffuse, darker, and emptier. Fortunately for us, and very surprising to theorists, says Martin Rees, lambda is very small. Otherwise, its effect would have stopped galaxies and stars from forming, and cosmic evolution would have been stifled before it could even begin. Number 5. The ratio of the gravitational binding force to rest mass energy, or Q. The seeds for all cosmic structures, stars, galaxies, and clusters of galaxies were all imprinted in the Big Bang. Q determines what might be called the texture or fabric of the universe and is thus fundamentally important. Its value is about 1 over 100,000. If Q were even smaller, writes Professor Rees, the universe would be inert and structureless. If Q were much larger, it would be a violent place in which no stars or solar systems could survive, dominated by vast black holes. Q, he continues, was imprinted in the very early universe, and the embryos of clusters and superclusters, structures stretching millions of light years across the sky, can be traced back to a time when the entire universe was a microscopic size. Number 6, the number of spatial dimensions, or D. This may seem a strange one to most of us, but it's crucial that there are 3 spatial dimensions. String theory holds that there were originally 10 or 11 dimensions at the birth of the universe, but that they were compacted into a lower number. Life couldn't exist, says Professor Rees, if D were 2 or 4. Together, these figures constitute what Martin Rees labels a recipe for a universe. If any one of them were lacking, we would be lacking as well. Yet each of these 6 numbers seems to be independent of the other. The value of one cannot be predicted, not thus far at least, from the value of any other, nor from the assembled values of the others altogether. The existence of stars, says Toronto-based theoretical physicist Lee Smolin, rests on several delicate balances between the different forces in nature. These require that the parameters that govern how strongly these forces act be tuned just so. In many cases, a small turn of the dial in one direction or another results in a world not only without stars, but with much less structure than our universe. The Oxford-trained molecular biophysicist Alistair McGrath offers another perspective. The early universe, he writes, produced nearly nothing other than hydrogen and helium, yet biochemistry requires and uses almost all of the chemically active, reasonably abundant elements in the upper half of the periodic table. The time required to manufacture abundant biological elements in stars with Earth-like planets is determined by the formation and evolution times of galaxies and stellar populations, setting a minimum age of billions of years. It's widely believed that the origins of life life require the formation of small planet-like bodies with chemistries and surface temperatures that are capable of supporting living organisms. Earth is believed to have been formed by a process of accretion from the solar nebula, leading to a series of defining characteristics, such as its chemical composition, atmosphere, and distance from the sun, which made it suitable for life. Why, asks the famous British cosmologist Stephen Hawking, is the universe so close to the dividing line between collapsing again and expanding indefinitely? In order to be as close as we are now, the rate of expansion early on had to be chosen fantastically accurately. If the rate of expansion 1 second after the Big Bang had been less by 1 part in 10 to the 10th power, that's 1 part in 10 billion, the universe would have collapsed after a few million years. If it had been greater by 1 part in 10 to the 10th power, the universe would have been essentially empty after a few million years. In neither case would it have lasted long enough for life to develop. If the electric charge of the electron had been only slightly different, stars would have been unable to burn hydrogen and helium, or else they would not have exploded. It seems clear that there are relatively few ranges of values for the numbers, that is, for the constants, that would allow for development of any form of intelligent life. Most sets of values would give rise to universes that, although they might be very beautiful, would contain no one able to wonder at that beauty. I'm now going to mention a number that's far, far larger than the number of grains on that Indian mathematician's chessboard. Please recall that 10 to the 10th power is equivalent to the number 1, followed by 10 zeros, or 10 billion. 10 to the 123rd power, by contrast, is 10 followed by 123 zeros. Imagine the number represented by multiplying the former figure by the latter. Okay. Now, do it again. That is just the number 10 to the 123rd. This is, anyway, you'll see. Sir Roger Penrose, who served for many years as the Rouse Ball Professor of Mathematics at the Mathematical Institute of the University of Oxford, is my source for that number. How big, he asks, was the original phase volume that the Creator had to aim for in order to provide a universe compatible with the second law of thermodynamics and with what we now observe? The Creator's aim must have been precise to an accuracy of 1 part in 10 to the 10th raised to the 123rd power. This is an extraordinary figure. One could not possibly write the number down in full in the ordinary denary notation. It would be 1 followed by 10 to the 123rd successive zeros. Even if we were to write a 0 on each separate proton and each separate neutron in the entire universe, and we could throw in all the other particles as well for good measure, we should fall short of writing down the figure needed. This is the precision needed to set the universe on its course. I cannot even recall, Penrose has written elsewhere, seeing anything else in physics whose accuracy is known to approach even remotely a figure like 1 part in 10 to the 10th to the 123rd power. But numbers in the same general ballpark abound. If, for example, the strength of gravity had been different by 1 part in 10,000 billion billion billion, writes Robin Collins, we would not exist. If the ratio of electron to proton mass were larger than it is, or smaller, chemical bonding would be insufficient for life chemistry. The allowable variation, some have calculated, is 1 part in 10 to the 37th power. This is an incredibly small number. Says Hugh Ross, a PhD astrophysicist who's turned a Christian evangelist. 1 part in 10 to the 37th power is such an incredibly sensitive balance that it's hard to visualize. The following analogy might help. Cover the entire North American continent in dimes all the way up to the moon, a height of about 239,000 miles. In comparison, the money to pay for the U.S. federal debt would cover 1 square mile, less than 2 feet deep with dimes. Next, pile dimes from here to the moon on 1 billion other continents the same size as North America. Paint 1 dime red and mix it into the billions of piles of dimes. Blindfold a friend and ask him to pick out 1 dime. The odds that he will pick the red dime are 1 in 10 to the 37th power. Where did the chemical elements that make up our water, rocks, and soils originate? The Big Bang only made hydrogen and helium atoms. There was no iron, no oxygen at that point, nor was there any carbon, which is essential to every form of life that we know. These heavier elements were formed in the nuclear furnaces of the first stars. But stars don't last forever. These elements were cast out into space as debris by the explosions of supernovae and the death throes of those earlier stars. Earth and other planets were formed from that debris. In order for carbon to come into existence, 3 helium nuclei must stick together, which involves a highly sensitive and delicate process. But many other elements are also needed. Oxygen, for example. That involves another helium atom sticking to the carbon. But the carbon will be lost if all of it turns into oxygen. Everything must be kept in precise balance until iron is reached. Stellar nucleosynthesis can't make anything on the periodic table beyond iron. However, heavier elements than iron are also needed, and they need to get out of the center of the star and become part of the general environment of the universe, so that planets like Earth, which contain these elements, can be formed. That's why the stars need to explode and scatter their elements. But the explosion itself must be of just the right type, so as to blow off neutrinos and cause the formation of heavier elements such as lead. I've already mentioned Einstein's cosmological constant, a number related to the rate of the universe's expansion, which he regretted as a mistake, but which in a roundabout way was eventually vindicated. The cosmological constant seems at first glance as if it could have been set at virtually any value, large or small, positive or negative. But in fact, most settings would have prevented the emergence of life. Thus, even Steven Weinberg, the atheist cosmologist at Princeton, whom I quoted earlier in the lecture, acknowledges that it does seem remarkably well adjusted in our favor. In fact, if the cosmological constant were not fine-tuned to within an extremely narrow range, 1 part in 10 to the 53rd power, or perhaps even in 10 to the 120th power of its theoretically possible range of values, the universe would expand so rapidly that all matter would quickly disperse, and thus galaxies, stars, and even small aggregations of matter would never form. According to philosopher Robin Collins, the odds of this occurring by random chance are roughly equivalent to those of hitting a bullseye on Earth, less than the size of a single atom, with a dart casually thrown from space. As physicist Stephen Barr comments, this is one of the most precise fine-tunings in all of physics. As Sir Fred Hoyle rather dejectedly wrote, "It's as if a super-intellect has monkeyed with the physics, as well as with the chemistry and the biology, and there are no blind forces worth speaking about in nature." His comment, observes Alistair McGrath, points to the deep unease contemporary cosmology has created for those not willing to believe in God. Might the evidence be better explained by the idea of divine creation than by happenstance? Hoyle certainly hoped not, but it rather looked that way to him. Permit me to say something about the depressingly prolific theologian Alistair McGrath, who currently teaches at King's College London, and whom I've cited at several previous points in this lecture. He earned a doctorate in divinity from the University of Oxford. But prior to that, beginning his studies as an atheist, he had already earned an Oxford doctorate in molecular biophysics. And he continues to publish book after book, not only in historical and systematic theology, but on apologetics and on the interface between science and Christian faith. The more I examine the universe and study the details of its architecture, remarks the Anglo-American mathematical physicist Freeman Dyson, long associated with the Institute for Advanced Study at Princeton, the more evidence I find that the universe must, in some sense, have known that we were coming. The late astronomer, NASA physicist, and cosmologist Robert Jastrow, a self-proclaimed agnostic, famously concluded his 1978 book, God and the Astronomers, which he reissued in 2000, with these words: "For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He is about to conquer the highest peak. As he pulls himself over the final rock, he's greeted by a band of theologians who've been sitting there for centuries." Allow me to introduce Anthony Flew. After the death of Bertrand Russell in 1970, he was very possibly the 20th century's most prominently outspoken atheist philosopher. Certainly he was so in the English-speaking world. But in 2007, he renounced atheism and in its place adopted a form of deism. The world picture that has emerged from science, he explained, drove him to believe in a creator or designer, a divine source for the orderly cosmos that science has revealed. Some critics allege that having grown old and fearing death, Flew had converted in order to gain the comforting solace of immortality. But he clearly rejected the idea of immortality even after his acceptance of deism, and he died in 2010. As the evangelical philosopher Douglas Groothuis observes, Flew made no leap of faith. He remained a philosopher who wanted to follow the argument wherever it leads. He simply found the apparent evidence for intelligence and non-randomness convincing. Not everybody, though, has reacted this way. Another response to the apparent fine-tuning of the universe is what might be called the ho-hum or so-what reply. Of course the constants of the universe are set in such a way to make our lives possible. If it weren't so, we wouldn't be here, and thus we wouldn't be observing them. This is simply the way things are, a brute fact, end of question. But such a response seems rather unscientific and incurious. Aren't we supposed to always be asking why? Isn't that the wellspring of science? Philosophy, says Plato's Socrates, begins in wonder. Doesn't science too? Imagine that you're standing against a wall in front of a firing squad about to be shot. You're blindfolded now with a target on your chest, but earlier you saw 50 soldiers armed with rifles enter the area where you are. You hear the officer order them to take aim. You hear him give the command fire, and you hear the roar of 50 rifles firing at close range. To your surprise, though, you don't seem to have been hit, not even a scratch. How would you react? You could perhaps simply shrug it off. Of course they missed you. If it weren't so, you wouldn't still be standing there. And thus you wouldn't be thinking about the matter. That's simply the way things happened, a brute fact, end of question. I think it very unlikely that you would react in this way. I think that you would be curious, you would make inquiries. Another version of the ho-hum response is nicely summarized by Alistair McGrath. Some argue that apparent cosmic fine-tuning is nothing more than an interesting happenstance. The fundamental constants in question had to have some value, so why not these ones? They need possess no further significance. To give an example, the population of the United States of America is over 300 million. There's only one president. The odds of any one American becoming president, that's 1 in 300 million. But so what? Someone has to be president. It may be highly improbable that any given individual should be president, but it's a certainty that someone will be. Or put it this way, my illustration. I shoot an arrow at the side of a barn. Then I walk over and carefully draw the concentric rings of a target around the arrow I just shot. Is anybody watching this performance likely to be impressed with my bullseye? Back to Alistair McGrath. At one level, he writes, it's impossible to refute this argument, yet it's clearly inadequate to account for the actualization of a highly improbable scenario, the emergence of a universe adapted for life. There is, for me, comments the English physicist and cosmologist Paul Davies, powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. It would be very difficult to explain why the universe should have begun in just this way, remarks Stephen Hawking, except as the act of a God who intended to create beings like us. I think there are clearly religious implications, summarizes Hawking's biographer, John Boslow. But Stephen Hawking apparently rejects those religious implications, as for that matter does Martin Rees. The leading alternative explanation for fine-tuning currently on offer is the notion of a multiverse. According to the inflationary model proposed by Alan Guth in 1981, the universe expanded so rapidly that there are vast tracts of it, many times larger than the universe we see, of which we can know absolutely nothing, because light, the bearer of all information, has not had time to reach us from them. And in fact, if, as some think, the expansion of the universe is accelerating, such light will never reach us. They are not, and perhaps never will be, observable by humans. Within each of these bubble universes, it's proposed, the physical constants may be different. In other words, we may simply have been lucky. We happen to live in a livable universe. But is this really an improvement, more scientific than positing the existence of a divine mind at the origin of the cosmos? Does it not perhaps run afoul of Occam's famous razor, which is sometimes expressed in the rule, entities must not be multiplied beyond necessity? And does the multiverse hypothesis really eliminate the problem? First of all, the distinction between a universe and a multiverse seems essentially a semantic one, since as most people use the term, the universe is the totality of physical reality. As the late Carl Sagan famously put it, the cosmos is all that is or was or ever will be. But even ignoring that reservation, if we and all of our empirical data are limited to the particular universe in which we find ourselves, how can we know whether or not our natural laws, or any particular natural laws, or indeed any natural laws at all, apply in another one or to the multiverse as a whole? And yet if they don't, or if we don't know that they do or don't, how can we confidently draw any conclusions about the realms beyond our universe from observations made within it? Humility is in order. Science cannot answer every question. Cosmologists sometimes claim, writes Sir Martin Rees, that the universe can arise from nothing, but they should watch their language, especially when addressing philosophers. We've realized ever since Einstein that empty space can have a structure such that it can be warped and distorted. Even if shrunk to a point, it is latent with particles and forces, still a far richer construct than the philosopher's nothing. Theorists may someday be able to write down fundamental equations governing physical reality, but physics can never explain what breathes fire into the equations and actualizes them in a real cosmos. The fundamental question of why is there something rather than nothing remains the province of philosophers, and even they may be wiser to respond with Ludwig Wittgenstein that whereof one cannot speak, one must be silent. Here's an image from a sonnet written by the American poet Edna St. Vincent Millay, who died in 1950. Upon this age that never speaks its mind, this furtive age, this age endowed with power to wake the moon with footsteps, fit an oar into the rowlocks of the wind, and find what swims before his prow, what swirls behind. Upon this gifted age, in its dark hour, rains from the sky a meteoric shower of facts. They lie unquestioned, uncombined. Wisdom enough to leach us of our ill is daily spun, but there exists no loom to weave it into fabric. She speaks of a meteoric shower of facts that requires a loom to weave it into fabric. Theism, it seems to me, offers a reasonable loom for the facts to which I've briefly and incompletely alluded in this lecture. It's difficult in this world to envision indisputable proof for any great overarching worldview, whether some variety of theism or, for that matter, atheism. Contemporary atheists who like to boast that they and they alone constitute the reality-based community go far beyond the available evidence in that assertion. Reason, as Beatrice tells Dante in Paradise, has short wings. For we walk by faith, wrote the Apostle Paul to the Corinthians, not by sight. For we know in part and we prophesy in part. But when that which is perfect is come, then that which is in part shall be done away. For now we see through a glass, darkly, but then face to face. Now I know in part, but then shall I know even as also I am known. But to say that there is no indisputable proof is not to concede by any means that there are no clues. A clue suggests, but by itself doesn't prove. However, if clues pointing in the same direction begin to multiply, their cumulative force can be considerably greater in assembly than in isolation. In a criminal trial, a jury has the responsibility to decide which explanation of the clues that have been presented, that offered by the prosecution or that put up by the defense, provides the most persuasive account. No certain proof may have been offered, certainly nothing on the level of a proof in geometry or deductive logic. But if enough clues point in the same direction, confidence in that to which they point is rationally justified. The American philosopher Charles Sanders Peirce argued that the characteristic form of thinking in science is neither rigidly deductive nor entirely inductive, but rather is what he called abductive inference. A surprising fact, C, is observed. If, however, A were true, C wouldn't be so surprising. Therefore, it's reasonable to suspect that A is true. I've tried in this lecture to call attention to a few surprising facts. I think they can be read and read very well theistically. In the 13th century, the Franciscan philosophical theologian St. Bonaventure, in his treatise on the mind's journey to God, that many natural features can be seen as shadows, echoes, and pictures of the Creator, which are set before us in order that we might know God. The pursuit of discovery, as the late chemist and philosopher of science Michael Polanyi wrote, is guided by sensing the presence of a hidden reality toward which our clues are pointing. The gospel isn't about science and shouldn't be seen as an attempt to supplant the work of scientists. As Alistair McGrath remarks, natural theology has been seen as offering an explanation of reality, yet the Christian faith is about the transformation of all things, an idea better explained in terms of salvation rather than explanation. Surely this emphasis upon explanation represents something of a distortion of the fundamental themes and emphases of Christianity, does it not? Amid the controversies surrounding the work of Copernicus and Galileo, Caesar Cardinal Baronius, who died in 1607, famously explained that the Bible teaches us how to go to heaven, not how the heavens go. Still, our whole business in life, in this life, said St. Augustine, is to heal the eye of the heart so that God might be seen. Credo ut intelligam, wrote St. Anselm of Canterbury in his 11th century proslogion. I believe so that I may understand. And behold, all things have their likeness, says the Lord in the book of Moses, and all things are created and made to bear record of me, both things which are temporal and things which are spiritual, things which are in the heavens above and things which are on the earth, and things which are in the earth, and things which are under the earth, both above and beneath. All things bear record of me. Mercifully, I draw near the long-awaited close of this lecture with passages from Elizabeth Barrett Browning's 19th century poem, Aurora Leigh, in which the poet reflects upon the twofold world in which, she says, we live. It's difficult not to think in this context of the Lord's statement to Joseph Smith in September 1830, that all things unto me are spiritual. Natural things and spiritual, who separates those two in art and morals or the social drift, tears up the bond of nature and brings death, paints futile pictures, writes unreal verse, leads vulgar days, deals ignorantly with men, is wrong, in short, at all points. No lily-muffled hum of a summer bee, but finds some coupling with the spinning stars. No pebble at your foot, but proves a sphere. No chaffinch, but implies the cherubim. Earth's crammed with heaven, and every common bush afire with God. But only he who sees takes off his shoes. The rest sit round it and pick blackberries. However compelling these and many other apparent hints of fine-tuning may be, They do not literally compel. I don't believe they were intended to do so. The seeming fine-tuning of the universe is an area where, in the words of John Polkinghorne, science can throw out questions that point beyond itself and transcend its power to answer. Religious belief, however, can suggest answers to such transcendent questions. As Alistair McGrath puts it, if nature is to disclose the transcendent, it must be seen or read in certain specific ways, ways that are not themselves necessarily mandated by nature itself. I do not argue, he says, that fine-tuning represents a proof of the Christian belief in God. I nevertheless insist that it is consonant with the Christian vision of God, which is believed to be true on other grounds, in that it offers a significant degree of intellectual resonance at points of importance. While this proves nothing, it is nonetheless deeply suggestive. Might it be, to use the luminous phrase of C.S. Lewis, a clue to the meaning of the universe? Certain facts are observed, which are indeed surprising, yet we can easily imagine a standpoint from which they are not surprising, and might even be anticipated. For religion, William James wrote, is essentially faith in the existence of an unseen order of some kind, in which the riddles of the natural order may be found and explained. William Paley's famous watchmaker argument has been generally rejected because he presumed that the features of the world around us have come into existence fully formed and remained static. But it's not clear that instantaneous creation and stasis thereafter were required for awe. There is, Darwin wrote in The Origin of Species, grandeur in this view of life, with its several powers, having been originally breathed into a few forms or into one, and that whilst this planet has gone cycling on according to the fixed law of gravity, from so simple a beginning, endless forms most beautiful and most wonderful have been and are being evolved. And there may well be religious meaning in it. Perhaps Paley's perception wasn't altogether wrong. His argument may fail as proof, but might serve as a powerful and still valid pointer. As Charles Kingsley expressed it in an 1871 lecture entitled The Natural Theology of the Future, we knew of old that God was so wise that he could make all things. But behold, he is so much wiser than even that he can make all things make themselves. The 19th century zoologist Ernst Haeckel is reported to have said that if he could have just one question definitively answered, it would be, is the universe friendly? The cosmology of the past few decades seems to be offering a positive answer to this query. Amidst the cacophony of the world in which we live, surrounded by its noisy moral, intellectual, historical, and aesthetic ambiguities, is it reasonable for some of us to claim that we nonetheless hear a melody? I've barely begun to scratch the surface in this overly long lecture, but my personal answer to that question is an emphatic yes.